The first challenge achieved in this project was to build a square chassis robot that navigates through a maze. This is made possible by programming the Arduino microcontroller with basic coding and delays responsible for the timed turnings. This is the code for the program on the first challenge. The basic coding here is pretty much the basic setting for the Arduino Mega microcontroller. At the top of it, I've declared my servo motors left and right and an input push button. So this is where the actual robot starts to run. The first step is pressing the push button, and this is delayed for 15 seconds, and that's when the motor starts to run. Both the motors start to run. The first step is moving forward. The robot does this for a second, it stops, and it delays. It stops for 2 seconds, and then it carries out its other action by turning left. So what the robot is doing is it would moves forward, makes a left turn, moves a little bit closer to the ramp, then makes a right, goes right up the ramp. As it gets off the ramp, it makes a right turn and then moves towards the right, and then ends by making a 360 spin. I decided to name the motor and to differentiate them on the program. So motor L represents the left one, and then motor R represents the right one. This function here serves as the angle of the motor. This value in here is the angle, which determines how much of a turn, either left or right, moving forward or stopping, the robot is expected to do. This delay here is the timing for the preceding event to occur. The robot makes a quick stop for about 2 seconds and then carries out another action. One of the problems encountered on the programming aspect of this was that it took quite a while to determine the precise or exact speed and duration the robot had to go through the maze. This was solved by multiple trial and errors to determine and adjust the angle of the motor for both left and right. The second problem after this was that the motor does not work above the angle 160 and not below 20. So this was our max and minimum angle for turning, either left or right, and stopping at 90 degrees precisely. The third problem was how long the battery lasted affected the timing. So this had to be kept off until used when needed. Because this involves gearing to determine the speed and torque the robot uses to drive through the maze, one mechanical problem I encountered was how the gear ratio affected the speed. But for the first part, the 36-tooth gear was driving the 60-tooth gear on both sides, which had a higher gear ratio. This meant that the speed was a bit higher, that it was making it difficult for the robot to make turns, and the timing was also affected. So the solution to this problem was to change the position of the
Now, why are you counting here instead of all the way up here?
Well, I mean, that was the suggestion of the code, but
Okay, so
if you go up,
Well, in this
Right,
case,
I mean, you're kind of doing this, but you can't really see.